Hey there everyone, welcome back to this channel. I am Nizian. Thank you so much for joining me in this mini lesson. Let's get ahead and get started. Okay. Since you have learned special products and factoring polynomials from your previous topic, your knowledge on those topics will help you better understand the lesson in this video. Let's start the lesson by recalling what is a rational number. Okay, a rational number is any number that can be written as a ratio in the form of a over b, where a and b are integers and b must not be equal to 0. Examples: negative 98, 6, 9.7, 5 over 6. Negative 98 has a denominator of 1, 6 has also a denominator of 1, and 9.7 can also be expressed as a fraction. But before that, let's recall or remember or describe what is an algebraic expression. Okay, algebraic expression involves numbers, correct? Correct. It also involves variable. Okay, what else? Okay, correct. Okay, from the definition or the description of algebraic expression and rational numbers, how can you then define or describe rational algebraic expression? Okay, formal definition: a rational algebraic expression or fractional expression is a quotient of two polynomials, say p and q, of the form p over q, where q must not be equal to 0. Okay, rational algebraic expression will cover up 0 and negative exponent, evaluation of algebraic expression, simplification of algebraic expression, operations in algebraic expression, complex fraction. But this video will only tackle about 0 and negative exponents. Example. Here are some examples of rational algebraic expression. Okay, I have here expressions. Let's classify whether these expressions are rational algebraic expressions or not. Okay, is m plus 2 over square root of 2 is a rational algebraic expression or not? Okay, it's not. Why? What could be the reason why this expression is not a rational algebraic expression? Okay, correct. The denominator here is square root of 2. And since from the previous definition, a over b, diba? Rational numbers are in the form of a over b, where a and b are integers. Okay, correct. Next, y plus 2 y plus 2 over y minus 2 is what? A rational algebraic expression. Next, k over k squared minus 6k is a rational algebraic expression. 1 over a raised to the power of 6 is also a rational algebraic expression. Next, square root of 5 minus m over m cubed is not a rational algebraic expression. What could be the reason why this expression is not a rational algebraic expression? Okay, correct. It is because of the square root of 5. Next, a over y squared minus x raised to the power of 9 is also a rational algebraic expression. C over a minus 2 is also a rational algebraic expression. C raised to the power of 4 over 8 root of 5 is not a rational algebraic expression. It is because of its denominator. Okay, evaluating rational expressions. To evaluate rational expression for a particular value or values, Substitute the replacement value or values into the rational expression and simplify the result. Example, let's evaluate the expression x squared minus 7x plus 5 over x plus x, where our x is equals to 0. So we now have 2 squared minus 7 times 2 plus 5 over 2 plus 6. We now have 4 minus 14 plus 5 over 8. Simplify. So we now have negative 5 over 8. Okay. What will happen if we try to evaluate the rational expression to x is equals to negative 6? Okay, let's try. Substituting the value of x to negative 6. Negative 6 raised to the power of 2 minus 7 times negative 6 plus 5 over negative 6 plus 6 is equals to 36 minus negative 42 plus 5 over 0 is equals to 83 over 0. The expression is undefined since the denominator becomes 0. The meaningful replacement are all real numbers except negative 6. A rational expression is undefined when the denominator is equals to 0. Note, to find all the meaningful replacement of the variable of the denominator, equate the denominator to 0, then solve for the variable. Okay, another example. What values cannot be used as replacement for the variable in each of the following expressions? 1. X plus 7 over x minus 4. First, let's equate the denominator to 0. X minus 4 is equals to 0 gives you x is equals to 4. Since x minus 4 cannot be equal to 0, x must not be 4. If we try to substitute 4 to the denominator becomes 0, correct? Correct? Okay. Next, y plus 8 over 3y minus 12. Equate the denominator to 0 gives you y is equals to 4. Since 3y minus 12 cannot be equal to 0, y must not be equal to 4. Again, if you try to substitute y to 4, the denominator here becomes 0. Okay, next. X plus 4 over x squared plus 5x plus 6. First, set the denominator to 0 or equate the denominator to 0. Since we cannot just easily find the value of x for this expression, you need to factor out the denominator. So the factors of x squared plus 5x plus 6 are x plus 2 times the quantity of x plus 3. Equate the factors to 0. X plus 2 is equals to 0 gives you x is equals to negative 2. X plus 3 equate to 0 gives you x is equals to negative 3. Since x squared plus 5x plus 6 cannot be equal to 0, then x must not equal to negative and negative 3. If you try to equate or substitute negative 2 and negative 3 to the denominator, it will give you, or it will become 0. Okay, rational algebraic expression. Since we already defined what is a rational algebraic expression, and you have already learned or have some example, let's proceed to 0 and negative exponents. Okay, b raised to the power of negative 4 is equals to 1 over b raised to the power of 4. It is because from the definition of negative exponents, a negative 1 is equals to 1 over a raised to the power of n. Any number that is raised to negative power, it can also be expressed as a reciprocal to the base raised to its exponents. Next, n squared m minus 3 is equal to n squared over m cubed. It is also from the definition of negative exponent. A raised to the power of negative n is equals to 1 over a raised to the power of n. Next, x plus y is equals to the quantity of x minus y raised to the power of 0 is equal to x plus y. It is from the definition of zero exponents. Any number or any non-zero number raised to the 0 power has always the value of 1. Okay, that's it for our lesson. Thank you again for stopping by. I hope you find it helpful. And if you did, click the link below and subscribe our YouTube channel. You can leave a thumbs up, any comment on this video. We could really use your support. And don't forget to subscribe our channel.